How do we add and subtract vectors? If vector A is given as x1, y1 and vector B is given as x2, y2, then vector A plus vector B is x1 plus x2, y1 plus y2. So all we need to do is to add the two x components and we add the two y components. In the same way, vector A minus vector B will give you x1 minus x2, y1 minus y2. So we subtract the x component from one x component, then we subtract the y component from the other y component. Let's pick some examples and see how to do this. So we have vector A 2, 7, vector B 1 minus 2, and vector C -3, -5. And we are supposed to find A plus B, B plus C, B minus C, A plus B minus C. Let's pick the first one, which is A plus B. We know that A is 2, 7, B is 1 minus 2. So A plus B will give us 2 plus 1. So we have 2 plus 1 here. Then 7 plus minus 2. We know from algebra that 7 plus minus 2 is the same as 7 minus 2. So we go ahead. 2 plus 1 is 3. 7 minus 2 is 5. So A plus B will give us 3, 5. It's very simple. The next one is B plus C. B is 1 minus 2. C is -3 minus 5. So B plus C will give us 1 plus -3, which is 1 minus 3. -2 plus -5, which is -2 minus 5. 1 minus 3 is -2. -2 minus 5 is -7. So B plus C is -2 minus 7. The next one is B minus C. So we have B to be 1 minus 2. C is -3 minus 5. So B plus C will give us 1 minus -3, which is 1 plus 3. We know this from algebra. 1 minus -3 will give us 1 plus 3. Then we have -2 minus -5, which will give us -2 plus 5. Okay, 1 plus 3 is 4, -2 plus 5 is 3. So B minus C will give us 4, 3. The last one is A plus B minus C. A is 2, 7, B is 1 minus 2, and C is -3 minus 5. So A plus B minus C will give us 2 plus 1, which is 2 plus 1. 2 plus 1 minus -3. So this will give us 2 plus 1 plus, because minus -3 will give us plus, so plus 3. Then the y component is 7 plus -2. So 7 plus -2 give us 7 minus 2. Then -5, so that will give us plus 5. 2 plus 1 plus 3 is 6. 7 minus 2 plus 5 is 10. So A plus B minus C is 6, 10. What are equal vectors? Two vectors are said to be equal if they have the same magnitude and direction. So if vector A is given as x1, y1, and vector B is given as x2, y2, and vector A is equal to vector B, then x1, y1 is equal to x2, y2. So x1 is equal to x2 and y1 is equal to y2. So if two vectors are equal, then the x component of one vector is equal to the x component of the other vector, and the y component of one vector is also equal to the y component of the other vector. If you have two vectors like that, we say that they are equal, and those two vectors will have the same magnitude and direction. You will find out more about this as the study goes on. For now, what you have to know is that if two vectors are equal, the x component of one vector is equal to the x component of the other vector, then the y component of one vector is also equal to the y component of the other vector. Let's use this information to solve some questions. We have been given two questions here. Given that x is equal to x minus 4, then 3, and t is equal to 5 and 3 minus y, find x and y if x is equal to t. And the second one is p is equal to 4x plus 3, 5 plus 2y, and q is equal to 11 minus 5. Find x and y if p is equal to q. Let's take them and solve them one after the other. So we pick the first one. We have x to be equal to x minus 4 and 3. Then t is 5 and 3 minus y. The question says that vector s is equal to vector t, as you can see here. Now, because vector s is equal to vector t, we can say that x minus 4, 3 is equal to 5, 3 minus y, because this is vector s and this is vector t. We have learned that if two vectors are equal, then what it means is that the s component of one is equal to the s component of the other. So here, x minus 4 is equal to 5. X minus 4 is the s component of this vector x here. 5 is the s component of this vector t. So x minus 4 is equal to 5. This is linear equation. We've solved a lot of linear equations. So what do you do here? We make s the subject. So you send negative 4 over to this side. So s will give us 5 plus 4 and x is 9. In the same way, the y component here, which is 3, is equal to the other y component, which is 3 minus y. So we can say that 3 is equal to 3 minus y. If you are making y the subject or we are finding y is negative here. So if I send it over to this side, it becomes positive. Then I'll send the 3 here, which is positive, over here. It becomes negative. So y is equal to 3 minus 3 and y is equal to 0. So we can say that x is equal to 9 and y is equal to 0 if vector s is equal to vector t. Let's take the second question. 4x plus 3, 5 plus 2y for p, and for q we have 11 minus 5 and p is equal to q. Now if p is equal to q, we can say that 4x plus 3, 5 plus 2y, which is vector p, is equal to 11 minus 5, which is vector q. So from here, we know that this s component here is equal to this s component here. So we can say that 4s plus 3 is equal to 11. We know from linear equations that when you get this, you have to group like terms. So you have 4x is equal to 11 minus 3. 4x is equal to 8. You divide both sides by 4. You've done a lot of this under linear equation. So if you want to understand how to solve this linear equation, watch the video on type 1 of linear equations. We solved a lot of these examples there. So x is equal to 2. In the same way, you can see that the y component here is also equal to the y component here. So 5 plus 2y is equal to minus 5. Once again, you group like terms. So you have 2y is equal to minus 5 minus 5. 2y is equal to minus 10. You divide both sides by 2 and y will give us minus 5. So we can say that s is equal to 2 and y is equal to minus 5 if vector p is equal to vector q. If p is equal to 2, 1, q is equal to 1, 1, and r is equal to 13, 7, and kp plus mq is equal to r, where k and m are real numbers. Find the values of k and m. Okay, so we see here that we have these vectors here, kp and mq, and when you add them, it's equal to this vector here, which is vector r. So the first thing we need to do is to find the vector kp and we find the vector mq. We add them and we equate it to the vector r. We already know r to be 13, 7. The question says that k and m are real numbers. So here k and m are scalars. So we are going to use these scalars to multiply the vectors that we have here. We've already learned how to multiply a vector by a scalar. We have p is equal to 2, 1, q is equal to 1, 1, and r is equal to 13, 7. So we tackle the first part, which is kp. Kp means that use the scalar k to multiply the vector p. So we have k times the vector p, which is 2, 1. So k will multiply the s component. So k times 2, which will give us 2k. Then k will multiply the y component, which is 1. So k times 1, which is k. So the vector kp will give us 2k plus 2k k. Let's go on to the second part, which is mq. Mq means that use the scalar m to multiply the vector q. We've learned how to use scalars to multiply vectors. So m times q, which is 1, 1. So m will multiply 1 as the s component to give us 1, and m will multiply 1 as the y component, which will give us, so the first one will be m times 1, which is m. Then m will multiply 1 again. You have m times 1, which is m. So the vector mq is mm. The vector kp is 2k k. The question says that kp plus mq is equal to r. We have now found kp. We have found mq. So we can say that kp, which is 2k k, plus mq, which is mm, is equal to r. R is 13, 7. I hope that is clear. We know from addition of vectors that 2k k plus mm will give us 2k plus m, k plus m. You learned this in addition of vectors. So this is equal to 13, 7. We just learned under equal vectors that if two vectors are equal, then the s component of one vector is equal to the s component of the other vector. Now, because these two vectors are equal, we can say that 2k plus m is equal to 13 and k plus m is equal to 7. So 2k plus m is equal to 13, we will call that equation 1, and k plus m is equal to 7, we will call this equation 2. We have these two equations here, and we have two variables, so we can solve these two equations simultaneously to find k and m. We solved a lot of simultaneous equations under the videos on solving simultaneous equation, linear simultaneous equation in two variables. So here we are going to go straight ahead and find the value of k and m by solving the two equations simultaneously. As I said, I'm not going to explain how to solve the simultaneous equation here because I've already done that under the videos on simultaneous equation. So if you want to understand how to solve simultaneous equation, go and watch those videos and you understand it very well. So here, I'm going to subtract equation 2 from equation 1, and this will give me 2k minus k plus m minus m minus is equal to 13 minus 7. So 2k here minus k plus m minus m is equal to 13 minus 7 because we are doing it this way, equation 2 minus equation 1. M minus m will cancel out to give us 0. So we have k plus 0 is equal to 6. So k is equal to 6. So we found the first one, which is k is equal to 6. We need to find m. We know that we are going to substitute k is equal to 6 into equation 2. Equation 2 is k plus m is equal to 7. So if you replace k with 6, we just found that k is 6. So we are going to have 6 plus m is equal to 7, and m is equal to 7 minus 1. 7 minus 6. So m will give us 1. So we can say that k is equal to 6 and m is equal to 1. So you see that in this video, we applied multiplication of a vector by a scalar, we applied addition of vectors, and we also applied equal vectors, And we have also applied solving simultaneous linear equation in two variables. So make sure you understand all these things so that you'll be able to solve questions of this nature. Once again, if you want to understand how to solve simultaneous linear equations, I've explained them in the videos on solving simultaneous linear equations in two variables. If you watch those videos, you understand this very, very well. What are parallel vectors? Two non-zero vectors are said to be parallel if one is a scalar multiple of the other. What does this mean? This means that if you have a vector, let's say vector x, and the coordinates are a, b, and you have another vector which is vector y, and vector y is a scalar multiple of vector x. Now you can see that we are using this scalar k to multiply the components of x, a, b. So vector y, which is the scalar multiple of vector a, will give us ka, kb, because when you do this, you use k to multiply a and you use k to multiply b. So you get ka, kb. We say that these two vectors, x and y, are parallel vectors. So if one vector is a scalar multiple of the other, that is, you got one vector by multiplying the other vector by a scalar, a number, then we say that these two vectors are parallel vectors. I hope that is clear. So here vector s is ab and vector y is k times ab, because we got vector y by multiplying vector s by a scalar or a number. We say that these two vectors x and y are parallel vectors. Let's learn more about parallel vectors. Remember that, as we said under multiplication of vectors by scalars, the scalar can be positive or negative. If the scalar is positive, it means that the two vectors will move in the same direction. If the scalar is negative, it means that the two vectors will move in opposite directions. But how do we find parallel vectors? How do we know that two vectors are parallel when they are being given to us? Here we are saying that if s is ab, vector s is ab, the components are ab, and the components of vector y are cd, and x is parallel to y, or x and y are parallel, then if you divide the s component of this vector by the s component of this vector, the value that you get should be the same as dividing the y component of one vector by y component of the other vector. Hope that is clear. So if vector x is parallel to vector y, then if you divide a by c, you should get the same answer as dividing b by d. Let's pick some examples and solve. You are supposed to investigate whether the following vectors are parallel. We are investigating whether these two vectors are parallel. And the second example, we are finding x if these two vectors are parallel. Let's pick the first one. Investigate whether 28 and negative 15, negative 6 are parallel to each other. As we said, if 28 and negative 15, 6 are parallel to each other, then 20 divided by negative 15 must be equal to 8 divided by negative 6. If they are parallel, then these two fractions must be the same. The x component here divided by the s component here should be the same as dividing the y component by the y component. So let's first find 20 divided by minus 15. That will give us minus 4 over 3. If you punch this on your calculator, you are going to get minus 4 over 3. If you punch 8 divided by minus 6 also on your calculator, you will see that you get minus 4 over 3. So it means that 20 divided by minus 15 is the same as 8 divided by minus 6. So we can say that since 20 divided by minus 15 is equal to 8 divided by minus 6, the two vectors are parallel to each other. Let's take the second one. We are supposed to investigate whether these two vectors are parallel. But we know that for these two vectors to be parallel, then 2 divided by minus 4 should be the same as minus 6 divided by minus 12. So first, we find out what is 2 divided by minus 4. That will give us minus 1 over 2. Minus 4 divided by minus 6 divided by minus 12 will give us 1 over 2. Now look at something. The first one, which is 2 divided by minus 4, so 2, the s component here, divided by the s component here, 2 divided by minus 4, is giving us minus 1 over 2. But the y component here, which is minus 6, divided by the y component here, which is minus 12, is giving us 1 over 2. These two numbers are not the same. Minus 1 over 2 is different from 1 over 2. And because they are not the same, we say that since 2 divided by minus 4 is not equal to minus 6 divided by minus 12, the two vectors are not parallel to each other. So for the two vectors to be parallel to each other, the s component divided by the s component should be the same as the y component divided by the y component here. I hope that is clear. Let's take the other question. Find the value of x if 12x is parallel to 8, 6. We know that for two vectors to be parallel, for these two vectors to be parallel, then the s component here, which is 12, divided by the s component here, which is 8, must be equal to or is equal to the y component here, which is x, divided by the y component here, which is 6. The question told us that the two vectors are parallel, so we know that 12 divided by 8 is equal to x divided by 6. We have a linear equation here. We can solve it for x. So here, this linear equation involves fractions. When we are solving linear equation that involves fractions, we said that you find the LCM and you multiply the terms in the equation by the LCM. The LCM of 8 and 6 is 24. So you multiply the left hand side by 24, you multiply the right hand side by 24. When you do that, you can see that 8 will cancel itself 1 and cancel 24 6 times. 6 will cancel itself 1 and cancel 24 8 times. Now, you are going to have 6 times 12 is equal to 8 times x. 6 times 12 is 72. From algebra, we know that 8 times x is 8x. How do we find x here? We know from linear equations that you are going to divide both sides by 8. And when you do that, x is equal to 9. So using the principles of parallel vectors, you have been able to find x as 9. One thing you need to remember under parallel vectors is that if two vectors are parallel, then it means that the s component of the first one divided by the s component of the second one will give you the same answer as the y component of the first one divided by the y component of the second one. Two vectors are said to be perpendicular if the angle formed between them is 90 degrees. So if you have two vectors such that when you draw them on a diagram, the angle formed between them is 90 degrees, we say that those two vectors are perpendicular. How will you know if two vectors given to you are perpendicular? If vector A is x1, y1 and vector B is x2, y2, and vector A and vector B are perpendicular, then x1 times x2 plus y1 times y2 is equal to 0. So if two vectors are perpendicular, if you multiply the s components and you add it to what you get when you multiply the y components, you should get 0. So as you can see here, x1 times x2, which are the two s components, their product, plus the product of the two y components, y1 times y2. When you add these two products, you should get 0. Let's pick some questions and see how to apply this in solving questions. We have two questions here. The first one says that we should investigate whether the following vectors are perpendicular. Then the second one says we should find x if these two vectors are perpendicular. So let's pick the first one. We are going to investigate whether -4, 3 and 8, -6 are two perpendicular vectors. We said that if these two vectors are perpendicular, then minus 4 times 8 plus 3 times minus 6 must be 0 or must be equal to 0. So what you do is that you find minus 4 times 8, you find minus 4 times 8 plus 3 times minus 6. If it's 0, then it means that these two vectors are perpendicular. So we are going to do that on our calculator. So minus 4 times 8, then plus 3 times minus 6. So plus 3 times minus 6. And what do we get? We are getting minus 50. When you find minus 4 times 8 plus 3 times minus 6, we are getting minus 50. But we said that if these two vectors are perpendicular, when we find it, we should get 0. So since minus 4 times 8 plus 3 times minus 6 is not equal to 0, the two vectors are not perpendicular. Because if they are perpendicular, then minus 4 times 8 plus 3 times minus 6 must be equal to 0. Let's pick the next question. Investigate whether minus 1, 3 and minus 3, minus 1 are perpendicular. Investigate whether these two are perpendicular. We know that for these two to be perpendicular, minus 1 times 3 times minus 3 plus 3 times minus 1 must be 0. So if these two vectors are perpendicular, then if you multiply the x component here by the x component here, and you add it to multiplying the y component by the y component, you should get 0. So what is minus 1 times 3? So from here, we are going to do this on our calculator. So minus 1 times minus 3, then you open another bracket, 3 times minus 1, and that is giving us 0. Now since this is giving us 0, we can say that minus 1 times minus 3 plus 3 times minus 1 is giving us 0. So the two vectors are perpendicular. So to find out whether the two vectors are perpendicular, multiply the x component here by the x component here. Then add it to what you get when you multiply the y component here to the y component here. If you get 0, then the two vectors are perpendicular. If you don't get 0, the two vectors are not perpendicular. Let's take the other question. Find the value of x if 9x is perpendicular to 6, 3. Now the question says that these two vectors are perpendicular. We know that if two vectors are perpendicular, then if these two vectors are perpendicular, if you multiply 9 by 6 and we add it to x times 3, we should get 0. If you multiply the x component by the x component and we add it to the y component by the y component, we should get 0. So 9 times 6 plus x times 3 should give us 0. 9 times 6 is 54. X times 3 from algebra, we know that that is 3x. We have to make x the subject, so you send 54 over to this side. So 3x is equal to minus 54. From linear equations, we know that we have to divide both sides by 3. So we divide the left-hand side by 3, we divide the right-hand side by 3, and x is giving us minus 18. So if these two vectors are perpendicular, then x is equal to minus 18. Finding the magnitude and direction of a column vector. In the introductory video to vectors, we said that a vector has both magnitude and direction. In this video, we are going to learn how to find the magnitude of a vector. In the subsequent videos, we will learn how to find the direction of a vector. And we are talking about a column vector here. If vector PQ is given as xy, or the component of vector PQ is xy, then the magnitude of vector PQ is written as you draw these two bars, then you put vector PQ in the bar. So when you see this, it means magnitude of PQ. When you see these two bars around vector PQ, it means that is read as the magnitude of PQ, or magnitude of vector PQ. The magnitude of vector PQ is given by square root of the x component plus the y component. So if you are given a vector like this x, y, and you are being told to find the magnitude of the vector, take square root of the square of the x component plus the square of the y component. So square root of this vector here, p, magnitude of this vector here, pq, is equal to square root of x plus square root of y, where x is the x component and y is the y component. Let's take some questions and see how to use this. Find the magnitude of the following vectors: PQ 9, 12, vector AB -3, -4, vector EF -7, 24. Let's take the first one, vector PQ 9, 12. As we said, the magnitude of this vector PQ is written as PQ, then you draw these bars around it. It's equal to square root of the x component squared, so 9 squared, plus the y component squared, 12 squared. So you do this on your calculator. You know that 9 squared is 81, 12 squared is 144. So square root of 81 plus 144, and this will give us square root of 225, sorry. When you do this on your calculator, you are going to have 15 units. You are going to have 15. We don't know the unit of this vector, so you write it as units. So you have 15 units. Okay, so the answer here, then we add units to it because the unit of this vector was not given to us. Let's go on to the second one, vector AB. And we are supposed to find the magnitude of vector AB. So the magnitude of vector AB is equal to the x component squared. So square root of the x component, which is -3 squared. Then square root of the y component, which is -4 squared. Now look at something here. You will see that here I place -3 and -4 in brackets. That is what you should do. When a component is negative, put it in a bracket when squaring it. This is what I mean. Now you see, when you are doing this on your calculator, you are going to have square root of -3. So you put the -3 in a bracket. Because it's a negative number, put it in a bracket. So -3 squared plus, then you bring another bracket, -4, then squared. You press equal to, and this is giving us 5. So -3 squared will give us 9, -4 squared will give us 16. 9 plus 16 is 25. So square root of 25 will give us 5. We don't know the unit, so 5 units. Now look at something. If you remove the brackets and you just write it as square root of -3 squared plus -4 squared, you are going to have math error. You are going to have math error. You will not be able to get your answer. So whenever one of the values is a negative number, make sure that when squaring the negative number, you put the negative number in a bracket. Okay, let's look at the last question for this video. Vector EF, and it's -7, 24. So here what we do is that the magnitude of vector EF is equal to square root of, because 7 is negative, put the negative number in a bracket. So you are going to have square root of, you bring your bracket, so -7, then you squared it, plus 24 is positive. You can choose to bring the bracket or not, you still get the same answer. But when it's negative, make sure that you put the negative number in a bracket before you square it. So plus 24 squared. As I said, 24 is positive, so you can choose to bring the bracket or not. And this will give us 25. -7 squared will give us 24, plus 24 squared will give us 576. 24 plus 576 will give us 625. You take square root of this on your calculator, you are getting 25. Once again, we don't know the unit, so 25 units. So the most important thing you need to know here is that 1. The magnitude of a vector is given by square root of the x component squared plus the y component squared. And when you are squaring the x component and the y component, if one of them is negative, put that component in a bracket before you square it. So to find the direction of a column vector, the first thing you need to do is to represent the vector on a diagram. We've learned how to represent column vectors on a diagram, so we are going to apply that here. After that, the direction of the vector is the total angle the vector makes with the geographic north by measuring in the clockwise direction. We know this from our studies on bearings, that bearings are taken from the geographic north in the clockwise direction. So the direction of the vector will be the total angle the vector makes with the geographic north when you measure clockwise. We are going to find out how to do that. Then we use the appropriate trigonometry ratios to find the required angles. So let's pick some questions and see how to do this. Find the magnitude and direction of the following vectors. Leave your answer in one decimal place. So you have been given 4 vectors and we are being told to find the magnitude and direction of each one of them. You solve the first one in this video, then you will consider the others in the subsequent videos. So the first one is find the magnitude and direction of vector AB. And vector AB has the components 1, 3. In the previous video, we learned how to find the magnitude of a vector. So magnitude of vector AB will give us square root of the x component squared, so 1 squared, plus the y component squared, so 3 squared. And this will give us square root of 1 squared is 1, 3 squared is 9. So we are going to have square root of 10. When you find square root of 10, you are going to get 3.2. Remember, we are leaving our answer in one decimal place, so 3.2. The units was not given to us, so 3.2 units. Let's move on to our main study for this video, finding the direction of vector AB. Don't forget that vector AB has the components 1, 3. The first thing we need to do when you want to find the direction of a vector is to draw the vector on a diagram. So in our studies on drawing vectors on a diagram, we said that when the x component is positive, you move towards the right, and when the y component is positive, you move upwards. So here what it means is that if A is our starting point, as we can see here, we move 1 towards the right since it's positive. Then we will move 3 upwards since the y component is also positive. So if you draw a line from 1 and another one from 3, they are going to meet at this point, and that point is called point B. So you see that this vector here, AB, now look at the direction of the arrow. So AB, so moving from A to B. Okay, now how do we find the direction of this vector here? We know from bearings that we take our bearings from the geographic north in the clockwise direction. On this diagram here, this is our geographic north. So we are going to take the bearing from this geographic north onto the line or onto the vector AB. So the line joining A to B. So it means that this is our direction, the angle here. If you call this angle theta, it means that this angle theta here is our direction. So what we have to do now is to find the value of theta. So remember that you always measure the bearing from the geographic north in the clockwise direction. And you are going to measure it from the geographic north up onto the bearing, up onto the vector, or you are going to measure it from the geographic north onto the line joining the vector or the 2 points. So the line joining A to B. So here if we take that, if you measure it from the geographic north onto the vector, we are going to get this angle here. So our job is to find the value of this angle, and that is exactly what we are going to do. Okay, so to find the value of this angle, I'm going to call this angle here angle theta. I'm calling this angle here angle theta. Now you can see that this forms a right angle triangle. Point A, point B, and the point here forms a right angle triangle with the 90 degrees at this side. We know that from this point here to this point is 1. You see, from A to this place is 1. So from here to this place is also 1. From A up to this point here is 3. So that point is also 3. So we have theta here. We have the opposite to theta to be 1. We have the opposite to theta as 1. We have the adjacent to theta as 3. And we want to find theta. So we are going to use tan because we have opposite, we have adjacent. So we can say that from this diagram, the direction of the vector AB is theta. Okay, now we can find theta from this right angle triangle here. If we use tan theta, we know that tan theta is equal to opposite, which is 1, divided by adjacent, which is 3. So 1 is opposite to theta, 3 is adjacent to theta. So tan theta is equal to opposite over adjacent, which is 1 over 3. Theta will give us tan inverse of 1 over 3. We know how to find tan inverse, right? So you switch on your calculator, you press shift tan 1 over 3. 1 over 3, then you close the bracket. You are going to have 18.434. The number goes on, but the question told us to leave our answer in 1 decimal place, so we are going to have 18.4 degrees. So we can say that the direction of the vector AB is 18.4 degrees. So this column vector here, we have been able to find its magnitude as 3.2 units, and you have been able to find its direction as 18.4 degrees. So you see that this column vector, we have written it in the magnitude bearing form. So the magnitude is 3.2 units and the bearing is 18.4 degrees. Find the magnitude and bearing of vector MN, and the components of vector MN are 4, -2. So to find the magnitude of vector Mn, we say that the magnitude of vector Mn is equal to square root of the x component squared, so 4 squared, plus the y component squared, which is -2 squared. Remember that if a component is negative, you have to put that component in a bracket before squaring it, so -2 squared. For this one, 4 is positive, so you can choose to either put it in a bracket or not. But if it's negative, make sure that you put it in a bracket before squaring it. So the magnitude of vector Mn is equal to square root of 4 squared plus -2 squared. And when you do this on your calculator, you are going to have 4.5 units. Remember, we are leaving our answer in 1 decimal place, so 4.5 units. Let's move on to the direction of Mn. Direction of Mn. When you want to find the direction of a column vector, the first thing you need to do is to draw the diagram for the vector. So you draw our x and y plane here. We are beginning from M. That is our starting point, and the ending point is N. Now, we are beginning from N. The x component is 4, positive 4. It means that we will move to the right, so 4 on the right. The y component is -2. It means that we will move downwards, so -2, so 2 downwards. As I said, you don't draw this thing to scale, so don't worry yourself with measuring it accurately. All you need to show is that you move away from M and you create a mark here and indicate it as 4. But make sure that 4 is longer than 2, because in natural sense 4 is longer than 2. So when you are drawing it, let's see it on the diagram that 4 is longer than 2. Okay, so you move 4 to the left and you move 2 downwards. So when you draw a line from 2 here and you draw a line from from 4 here, they are going to meet at this place, and where they meet is N. So you join M to N. Now look at the direction of the arrow. It's moving from M to N. Okay, so what is the bearing, or what is the direction? we take the direction from the geographic north. This is the geographic north. So we take the direction from the geographic north to the vector. I hope that is clear. So this is the vector. The line is the vector. So we are taking the direction from this geographic north to the vector. But we know that from this point here to this point here is already 90 degrees. Okay. So all we need to find is this angle here. If we're able to find that angle and add it to 90 degrees, we will get the direction of the vector MN. Okay. So how do we find that angle? I'm going to call that angle what we are looking for. I'm going to call it theta. Now, if I call this angle here theta, you can see that I can draw a small right angle triangle for it. With this point here as M, we have this angle here. Now, you can see at this point, that is where the right angle will be formed. So the right angle is formed here. So I'll bring that right angle here. And this side here is N, as we have on the diagram. We know that moving from this M to this point is 4. So it means that this length here is 4. Moving from this side here to N is 2. So it means that this length here is 2. And we have theta here. Considering theta, 2 is opposite to theta and 4 is adjacent to theta. So we have opposite, we have adjacent. We can use tan to find the value of theta. So we can, from the diagram, you can say that the direction of vector MN is equal to 90 degrees plus theta. So let's find theta and add it to 90 degrees. Tan theta is equal to opposite, which is 2, divided by adjacent, which is 4. So theta is equal to tan inverse of 1 over 2. If you find the tan inverse of 1 over 2 and you correct that to 1 decimal place, you are going to have 26.6 degrees. Okay, so we can say that the direction of MN is equal to 90 degrees plus theta, which is 26.6 degrees. And when you add this, you are going to have 116.6 degrees. So for vector MN, the magnitude is 4.5 units and the direction is 116.6 degrees. Find the magnitude and direction of BC, vector BC. The components of vector BC are -2 and 2. So as usual, magnitude of vector BC is equal to square root of -2 squared plus -2 squared. When you do this on your calculator, you are going to have square root of 8. Don't forget to put -2 in a bracket. So square root of 8. Now, we are writing our answer, we are correcting our answer to 1 decimal place. So square root of 8 corrected to 1 decimal place is 2.8. We don't know the units here, so 2.8 units. Let's move on to the second part, which is the direction. So direction of the vector BC. Don't forget that the components of vector BC are -2 and -2. We will draw our x and y plane here. The x component is negative, which means that we will be moving to the left. The y component is negative, which means that we will be moving downwards. So we move to the left, we start from B and move 2 to the left. We start from B and move 2 downwards. So -2. This one also shows -2. So you see the sign gives you the direction in which you should move. Once again, you see that here both components are 2. So make sure that the distance from B to 2 and the distance from B to this 2 are the same, because 2 and 2 are the same. That's why I said draw an appropriate diagram. Okay, so when you draw a line from 2 here and you draw another line from 2 here, they are going to meet at this point, and that will be the ending point, point C. So we will draw our vector BC as seen here. What is the bearing or the direction of this vector? We take the bearing from the geographic north, which is this point, in the clockwise direction. So we are going to take it from here up to the line joining B to C, or up to the vector BC. But we know that from the starting point here up to this point here is 180 degrees. That is 180 degrees. So what we really need to find is this angle here. If we find that angle and we add it to 180 degrees, we can get the direction of vector BC. We can get the direction of vector BC. So I'm going to call that angle, what we are looking for, I'm going to call it theta. I'm going to call that angle there theta. From here, I can draw a simple right angle triangle, because we can see from the diagram that this side here will be our 90 degrees angle. So it forms a right angle triangle. So here is point B. Here is point C. From this side to this side is 2, as seen here. From this side to this side is 2, as seen here also. Okay, so I have theta. 2 is opposite, 2 is adjacent. So I can use tan to find it. Now we will say that the direction of vector BC is equal to 180 degrees plus theta. I've already explained that. Theta is equal to, from the diagram, 2 over 2. Opposite is 2, adjacent is 2. Sorry, tan theta is equal to 2 over 2. So 2 over 2 is 1. So we can say that tan theta is equal to 1. Theta is equal to tan inverse of 1. Tan inverse of 1 is 45. So on your calculator, if you find tan inverse of 1, shift tan 1, you are going to get 45. Now, but the question says we should leave our answer in one decimal place. So it's going to be 45.0 degrees. 45.0 degrees to indicate the one decimal place. We are looking for theta in order to find the direction of BC. We know that the direction of BC is equal to 180 degrees plus theta. Theta is now 45.0 degrees. This is going to give us 22.225.0 degrees. So we can say that for the column vector BC with the components -2, -2, if you write it in the magnitude bearing form, the magnitude is 2.8 units and the bearing is 225.0 degrees, corrected to one decimal place. Find the magnitude and direction of vector PQ, and the components of vector PQ are -3 and 4. So let's start with the first part, which is the magnitude of vector PQ. We have done quite a number of this, so I'm sure that by this time you are conversant with it. So magnitude of vector PQ is equal to square root of -3 squared plus 4 squared. Once again, don't forget to put the -3 in a bracket because it's a negative number. So this will give us square root of 25. Square root of 25 is 5, but the question told us to leave our answer in one decimal place, so 5.0 units. Let's go on to the direction. To find the direction of this vector, the first thing you need to do is to draw the diagram for the vector. The x component is negative, so you move to the left. The y component is positive, so you move upwards. So the x component is negative, so we are moving to the left, and the number is 3. So we start from P and we will move 3 to the left. We are starting from P and we will move 4 upwards because the y component is positive, so 4 upwards. We draw a line from 3, we draw a line from 4, they will meet at this point here. So that point is point Q. So the vector is vector PQ. Look at the arrow, the direction of the arrow. It's moving from P to Q. That is the vector PQ. We want the direction. Remember, we said that we take the direction or the bearing from the geographic north, which is this line here, in the clockwise direction to the line or to the vector. So it's going to be this. We are going to take the bearing from the geographic north, which is this point, to the line joining P to Q, or to the vector PQ. So this is the direction of vector PQ. Now we know that from this geographic north or the zero line to this part here is 270 degrees. That is 270 degrees. That one we already know. What we don't know is this angle. So if you're able to find this new angle, and we add it to 270 degrees, we can get the direction of the vector PQ. Okay, so I'm going to call that the angle we are looking for. I'm going to call that angle theta. I use theta a lot in my examples. You can use any other variable and you can still find it. So I'm going to call that angle the angle theta. Now you will see that we are forming a right angled triangle here, with the right angle being at this place. So if I draw a simple right angled triangle for this, we can see that we have the right angle here. Now moving from this point here to Q is 4, so this side will be 4. From P to this point is 3, so here is also 3. So we have opposite, which is 4, and adjacent, which is 3. So I can use tan. We know that the direction of PQ is equal to 270 degrees plus theta, as we just explained. So we are finding theta. Tan theta is equal to opposite, which is 4, divided by adjacent, which is 3. So theta is equal to tan inverse of 4 divided by 3. And tan inverse of 4 divided by 3 corrected to 1 decimal place is 53.1 degrees. 53.1 degrees. If you watch the video on approximations, I explained how to use your calculator to correct a number to the nearest decimal place. So if you don't know how to do that, you can watch that video and you'll be able to understand how to use your calculator to correct tan inverse of 4 over 3 to 1 decimal place, and that is 53.1. So the direction of vector PQ is equal to 270 degrees plus theta, which is now 53.1, and this will give us 323.1 degrees. 323.1 degrees. So we can say that vector PQ, which is -3, 4 in the column or component form, is the same as 5 units, 323.1 degrees in the magnitude bearing form. So 5 units is the magnitude and 323.1 degrees is the bearing or the direction. So we saw quite a number of examples on finding the bearing and magnitude of a column vector. I'm sure you are conversant with how to solve it by now. Pick more examples and try your hands on it. The zero vector is a vector with zeros as its components. It is usually denoted by O, and the zero vector is given as vector O with the x component as 0 and the y component as 0. So whenever you see this a vector with the x component as 0 and the y component as 0, that vector is called the zero vector. What is a position vector? Let's say that we have this point B, in a plane, and the origin, and O is the origin of the plane. Now this is what we are talking about. We have our x and y plane. We have this point here, and we are calling that point B. The coordinates of point B are x and y, and O is the origin of the plane, and the coordinates of O are 0, 0. If we join point O to point B, you can see that in the direction of the arrow, we have created the vector OB. That is what we've been learning all along. So as soon as we join point O to point B, looking at the direction of the arrow, we have created this vector OB. Okay, so if point O is joined to point B, then this new vector that we've created, vector OB, is called the position vector of B. So because we are joining point O, which is the origin, to a point in the plane, point B, we call this new vector, vector OB, as the position vector of B. It means that we are considering the position of B in reference to O, or we are taking the position of B from O. So here we are considering the position of B in reference to point O or relative to point O. So we call the vector OB, the vector obtained by joining O to B, we call that vector the position vector of B. This new vector, vector OB, as we've come to know, is called the position vector of B. It can be written as small letter b with this accent on top of it, or small letter b with this line drawn beneath it, or just small letter b. So you see that in some books you see the position vector OB written as this. In other books you can see it written as this, and in some other books you can also see it written as small letter b. So what you have to know here is that if we join point O, which is the origin, to a point in the plane, the new vector, which is in this case OB, is the position vector of the point B. So OB is the position vector of B, and OB can be written as B, small letter b with this accent on top of it, or small letter b with this line drawn beneath it, or just small letter b. Now, what are the components of this position vector? We know that the coordinates of point B is xy. So if we form the position vector of point B, what are the components? Position vector of point B, which is OB or small letter b. So in our studies, I'll be writing the position vector in this way. I'll just be using the small letters to represent it. So position vector of B, which is the vector OB or small letter b, the components of this position vector will be the coordinates of the point. Here the point is point B with the coordinates xy. So the components of this position vector, the x component will be the x coordinate of the point B, and the y component will be the y coordinate of the point B. Let's pick some examples and make this clearer. For example, if you have the point A with the coordinates 2, 3 in the xy plane, and O is the origin, then if we join point O to point A, so in this case here, we are considering a new point here, and that point is point A. So in this case, the new point we are considering is point A. Okay, and the components of point A, the coordinates of point A are 2 and 3. And we have joined point O to point A. So this is the vector. We have joined point O to point A. Now you see, when you do that, you are going to create a new vector called OA. This new vector called OA is referred to as the position vector of A. I hope that is clear. So when you see OA, it means the position vector of A. When you see OE, it means the position vector of E. When you see OF, it means the position vector of F. When you see something like this, OG, it means the position vector of G. I hope that is clear. Okay, so let's continue. So if you have this point here, point A, with the coordinates 2, 3 in the xy plane, and O is the origin, and we join O to A, the new vector OA is the position vector of A, and the components of this position vector OA, which can also be written as small letter a, is the x coordinate of A will be the x component, and the y coordinate of A will be the y component. So here is the point, and these are the components of its position vector. So the component of the position vector for a point, the x coordinate of the point will be the x component, and the y coordinate of the point will be the y component of the vector. Similarly, if the position vector of the point D, which has the coordinates -1 and 2, is OD, so OD is the position vector of D. The component of this position vector OD, which can also be written as small letter d, is given as the s coordinate of the point D will be the s component of D, of the position vector D. Then the y component of the point D will be the y coordinate of the point D will be the y component of the position vector D. I hope that is clear. So when you have OF, it means the position vector of F, and it can be written as small letter f. The component of F will be the coordinates of the point F.